Today we are learning about the Pythagorean Theorem and how to prove that we know this theorem is correct. So to start, we're going to have one triangle, and I've labeled the triangle A, B, and C. Now I brought in 3 other triangles that are the same as the original triangle I had, and we'll find out why they are labeled all wonky in just a second. Now I'm going to arrange them in a particular way to set up our proof. So I'm going to line the triangles up like so. And look, do you see how C is in the middle of each one? So we have C there, C there, C there, and C there. Now, we're able to see that we have formed 2 new shapes. So the first shape is pretty obvious. It's the one all the way around what I just created. And then we have one right here in the center. It's a tilted square. And we know that because we have 4 right triangles, which have 4 right angles. And they're all in here. And then, to help with our proof, I'm going to bring in another shape right here. So this is C squared. It's just the shape we had before, but I just made a new one to show you. And the area is whatever C2 equals. Now, we're going to move C2 and hopefully not bump anything else. Move C2. We're going to keep this where it was. And we're going to have C2 off to the side right here. So that set us up for our proof and gave us a little background information. So now we're going to get into the actual proof. To get into our proof, we are going to be doing a little bit of rotating. So I'm going to carefully rotate this shape to come right here. It's hard with one hand, I'm sorry. And then I'm going to rotate this shape to come right here. So now we have 2 new shapes. No shapes are changing, it's just we arrange them in different positions. So now we're going to do some translating. So we are going to move this rectangle right here. It's not changing anything about it, it's just where it's located. And then we're left with 2 empty spaces. And you can see that in these empty spaces, we have B times B and A times A. So to help us better visualize this, I am going to bring in 2 more shapes to help us see this. So we have B squared right here because we have B times B. And then we have A squared because, as you can see, we have A times A. So we know that the areas of A times A is A squared, and B times B is B squared. So now we have this new shape. And to me, this shape looks like the exact one that we started with. And I know that because all of the sides are A plus B, B plus A, B plus A, and B plus A. And we know that because A plus B and B plus A is the same thing, just say it in different ways. So now I'm going to take away the original triangles we started with. They were important to setting up our proof, but now we have some new information that we can share. So I'm going to move these to the side. And then I'm going to bring down the C squared. So now we have A squared plus B squared equals C squared. And these 3 squares come from those 4 triangles that we used throughout our whole proof. These are the leftover parts, and they show us that A squared plus B squared has to equal C squared. I thought that the proof by rearrangement was pretty easy to understand. I think that was because it was a visual demonstration. I really liked that it created new shapes, and those shapes ended up being like A squared plus B squared equals C squared. I consider myself a very visual learner, so using the triangles to create these new shapes really helped me, and I think that if I was teaching this to students, this is a great way to do that because you show them the missing spaces and then you bring these shapes in to help them better understand. And it makes sense having, like, I liked that all the sides were labeled, so I was able to see the sides were A plus B all around, and then the middle was all C. That really helped me like solidify my understanding and helped me be able to understand this because I've never learned this before. And I think something challenging about this was, again, just like wrapping my brain around it. It took me a while to like set up this video and do this video because like as I was learning and researching, I was learning new things, and obviously I had to be able to explain this in my own way. So that took a while, but once I got it and used these visual representations, it really helped me, and it really allowed me to know how to understand this proof, not just to tell you, but to know for myself as well. For our second proof, we are discussing the parallel dissection. Here we have one triangle that is labeled ABC, and C is the longest side, so that means it is our hypotenuse. And I'm going to bring in some other shapes to help us. So right here we have this shape that fits right along in very nicely. Then we have this shape, comes in right here, and then we have this shape, comes around here. And we know what the area of these three triangles is because we have C right here. So we have C times C equals C squared. B times B equals B squared. And then A times A equals A squared. So we know that the area of these three shapes is C squared, B squared, and A squared. Now we are going to take A squared and do a little bit of a dissection with it. So on the other side, I placed a 1-inch tick mark on all of these sides. And then I connected the diagonal tick marks to each other to create this X shape. I cut that square into the 4 triangles, and now I have these 4 separate triangles. Now I brought back C squared, and now I'm going to lay these triangles on top of C squared. Now I brought back C squared, and now I'm going to lay these triangles on top of C squared. Here we have it. I have all 4 of those triangles along the perimeter of the C squared. Then we bring back B squared, and it fits perfectly inside. So on the exact bottom of this, we have C squared, and then I cut A squared into these 4 pieces, and then we have the B squared right on top. Once again, I took everything apart, and we still have, this was the C squared at the bottom, then these all 4 together equal A squared, and then right there we have B squared. So in conclusion, that tells us that A squared plus B squared equals C squared, and we got there by dissecting the shapes. What I liked about this proof was the dissection part. It really helped to have A and cut it into 4 pieces and then layer them on top of each other. I think that visually that really helped me understand it, and I think again for students that could be really helpful as well. It's similar to the first one I did, the proof by rearrangement in that way, and that's what I liked about it. But I think that also made it hard because it was hard for me to make sure I was cutting the triangles in the correct way so they all were able to fit on top of each other. So I think that the logistics of that were hard, but that was the way that I was able to understand it the best, and that's why those 2 proofs made the most sense to me, because I was able to visually see them and visually manipulate them to equal each other. So that made a lot of sense, and like to end up with a triangle or A squared plus B squared equals C squared just made a lot of sense to me and just made everything click in my brain. And all of the sources I used will be linked in the description because I'm not too familiar with iMovie, so that is where all my sources are.